I should start by noting that this video presupposes some foundational knowledge about using sine, cosine, and tangent. So SOHCAHTOA, what that means, in other words, the definition of sine and cosine and tangent, and that if we gave you, for example, this triangle and asked you to find x, that you could set up that for this angle, this is the adjacent side, the opposite side, and the hypotenuse, that we could then do, we want adjacent and hypotenuse. So cosine of 37 degrees equals cosine's adjacent over hypotenuse. So x over 12, multiply both sides by 12. And you could put that in your calculator and figure out the length of this side, the value of x. So if that's a little bit rusty or not quite familiar to you, then I would recommend that you pause this video, go do that review, and then resume this video when that's a little bit better refreshed. So what we want to look at here is inverse trig functions. So we had some inverse functions earlier in this unit. So an inverse function basically will undo what the original function did. We said one way to think of an inverse function is that it goes from the output back to the input of the original function. So let's just do a couple of these, and then we'll kind of do some comparisons here. If you want quick review, you can pause the video and just make sure that you can do these 2 points from the unit circle, even though they're in degrees. So the first one, 30 degrees, that would be this point. So a lot to the right, a little bit up. So sine of 30 degrees is 1/2. And then for this one, 135 degrees. So that would be 90 and then another 45 right there. That's like in the middle. So it's middle distance or middle length up, middle length, sorry, to the side, and then middle length up. Since this is left, the x is going to be negative, and since it's up, the y is going to be positive. Cosine is x, so that's going to give us negative √2/2. Okay, and I'm just going to clear out these so that we have a nice clean surface to look at. So what we just did here was using sine, we were given the angle and we found its sine, or we found its cosine. So we were given an angle and we found a trig value. So that's what regular trig functions do. You have the angle, you find the trig value. And so what that means is what an inverse trig function is going to do is go the other way. It's going to start from the trig value and backtrack to tell us what the angle is. So when we say, and this is the notation, the same as other inverse functions, this negative one's not an exponent, that just means inverse function. So what we would say is inverse sine of 1/2. What this is asking, and I'll type this here because I think it's a useful way to think of it. This is asking, what is the angle whose sine is 1/2? I'll space that out a little bit. So, well, there's a reason, of course, I just had these two questions on the left. So we would say, oh, the angle whose sine is 1/2, that's 30 degrees. And we can do it, of course, in radians and say pi/6. And similarly, this question, inverse cosine of negative √2/2, it's saying what angle has a cosine of this, of negative √2/2? And we know that because we just did it, it's 135. So that's what an inverse trig function is doing. It's starting from a trig value, backtracking to the angle. So essentially it's asking, what is the angle whose sine is 1/2, or in this case, what is the angle whose cosine is negative √2/2? Now I'll put the asterisk here. One of the things that you'll get to in pre-calc or further math, if you take that, is there's actually many angles, for example, that have a sine of 1/2. So if I kind of put back my little drawing. So we know 30 degrees has a sine of 1/2. But also 150 degrees if we did the coordinate there, it's still a half up. Y is still 1/2. So that has a sine of 1/2. And also, if we went all the way around, another 360, so then 390 degrees, that's the same thing, and so on. So there's actually an infinite number of angles that have a sine of 1/2. For our purposes right now, we're just going to go with the one that we actually care about. So first quadrant or second quadrant if we need it. And if I need to, I'll specify exactly where those answers come from. So that's what an inverse trig function means. So let's look at one in just a little bit more context here. So this triangle on the right, if we want to find this angle measure, well, one thing we could set up, and a good piece of advice is to always start by setting these up the same way. We're always going to start by setting them up as some trig function. So this is opposite over hypotenuse. So I'm going to do trig function, angle equals side over side. Doesn't matter whether you're looking for the angle or the numerator or the denominator, just set it up this way every time and then use algebra from there. So we have the trig function, the trig value. We need to backtrack to find the angle. So that's where we use inverse sine. If you've got your calculator, this is a good thing to practice. So it should be on most calculators second, and then the sine button above that, you'll see this sine -1. It won't work if you try to use an exponent there. It's got to be like second sine. And if we want kind of the intermediate step, inverse function undoes original function. So we just have theta equals inverse sine 3/8. And so this is what you would put into your calculator. Inverse sine of 3/8. And that would get you 22.024. We'll say for most of these, we'll probably round to the nearest tenth. So we'll say theta equals 22.0 degrees. And again, we can do these in radians as well. I'm just doing these in degrees for now. So that gives you an idea of what inverse sine and inverse cosine, and there's also inverse tangent, what they do. So let's do wrong button. Let's do one word problem. So pause, take a moment and read this. And with a lot of these, since they're dealing with physical things, it's a good idea just to draw a little diagram. Doesn't have to be great. So Elmer is a mile away from the launch pad. So I'll just, whatever, there's the launch pad. Here's Elmer. But we're going to say that, his eye, actually, I should do better because we want his eyes to be at that height if we're really thinking about it that way. So there's Elmer, there's the launch pad. I don't know how to draw a rocket. Oh, that's pretty good, actually. Okay, there's a rocket. You don't need to include the rocket in your drawing. What's important here is that this makes a triangle. We've got, and then there. So we've got a triangle. And we know certain lengths of that triangle. We know that Elmer is 1 mile from the launch pad. We know that the rocket is 1.5 miles straight up. And the fact that it's straight up means that this is a right triangle. And what we're looking for is the angle that Elmer is looking up at the rocket. Now that we have these inverse trig functions as a tool, we can set this up. So first thing we said is always start by setting it up the same way. This is opposite and adjacent, so that's tangent. So trig function, angle equals side over side. So I don't really need to put the over 1. What's important here is to get rid of tangent, we use inverse tangent. There's no such thing as dividing by tangent, right? Tangent doesn't mean anything without like this whole thing. Tangent is an operation or a process that we need to undo. That's why we have inverse tangent. Okay, so the intermediate step would be these two cancel. We get theta equals inverse tangent of 1.5. And as you're doing these in your calculator, just be aware of whether you're in degrees or radians. I'll be clear about which format we want the answers in, but but certainly you need to know which one you're getting. And so what we get is theta equals, and again, this will be like second tangent. That's where the inverse tangent button will be, or the function will be. We get 56 if we round it to the nearest, well, you don't really need to round much, 56.3 degrees, which we can also see makes sense with our picture that it's more up, so it's going to be kind of a steeper angle. One other context where this can show up is solving trig equations. So here's what those might look like, and we'll just do a couple of examples here. We're trying to isolate theta. That's what we're solving for. So we're just going to do some kind of standard algebra here. So we'll add 3 to both sides. We'll divide by 4 to get sine of theta by itself. And I'm just going to leave this as 3.7 over 4. No reason to simplify it or change format. I'm just going to put it in the calculator anyway. And then to undo sine, we do inverse sine. So we would have theta equals inverse sine of 3.7 over 4. That would go in the calculator, and rounded to the nearest tenth, and pause if you want to make sure you get that in your calculator correctly. But rounded to the nearest tenth would be, oops, I have it on my other screen, is 67.7 degrees. And just to do one more, same idea here. We're trying to get theta by itself. So start with that on both sides. It's 13.4. We can't do inverse tangent yet. You can only do inverse trig function when it's literally just like when it's just sine of something, you can do inverse sine. When it's just tangent of something, you can do inverse tangent. So we need to get rid of that too first. And we could do 13.4 over 2, but you know, why? I'm just going to put it in the calculator anyway. We can do inverse tangent on both sides. So intermediate step. And I keep saying intermediate step because you don't totally need to write it down, but you know, it can help, especially when you're just getting to know this stuff. So theta is inverse tangent of 13.4 over 2. And put it in your calculator, you will get theta equals 80, well, rounded to the nearest tenth, it equals 81.5 degrees. So the big things that we want to get from this are starting with what an inverse trig function means. So a regular trig function, you start with the angle and you can find a trig value from that. Inverse trig functions are used when you have the trig value and you want to backtrack and figure out what the angle is in the first place. So we did some examples with that, and these I should say will come up where, or could come up where we give you a trig value that's on the unit circle. So we do like, you know, inverse tangent of root 3 over 3, or something that that the value would be known from the unit circle. So that could come up. Or we could do things that like this, where you're not expected to know from the unit circle. They're just numbers and you put them in your calculator, and whatever you get, you get. So that's stuff to know. This is a good way to remember the meaning of what an inverse trig function is actually asking. It's saying, what's the angle that has a sine of 1/2 or a cosine of negative root 2 over 2? We showed how to use this in a word problem. If you get a word problem, very good idea to draw a picture if possible. And then we did a couple of trig equations just so we could see what it's like to solve for theta using an inverse trig function.